Hello friends, in this video we will discuss about virtual environment in Python. Before moving forward, let's take a moment and discuss why we need a virtual environment. Let's see what issues can occur if we don't use virtual environments in Python projects. Let's see how conflicts can occur in a Python project if we are using different version of Pythons. So here we have two directories, this Python v1 and Python p2. So in this directory we have configured Python version as 3.6.0 and in this directory we have configured the Python version as 3.10.12. So we have created a sample program, this Python version conflict.py, and we will run both the program using different versions of Python and we will see what problems we see. Here we have created a data class and we are printing it. And if in Python 3.10.12 directory also we have the same file. Let's execute this file in directory 1. Here if we run this file as using this Python, we get the error that the module is not found. Here if we run it, we are able to see the output. Now we have seen that if we are using different version of Python, their same code can cause problems. So when we create a project in Python, we specify a particular version of Python that all the developers will be using. Let's see how different version of a third-party library can create problems in a Python project. So here we have two directories, this library v1 and library v2. Let's check the Python version in both the directories. So we have this Python 3.8.10 configured here. And in directory 2 also we have configured Python 3.8.10. So the Python version is same in both the directories. Now let's open the sample file. We have created a library conflict.py file. Here we have created a sample project in Pydantic, which is a third-party library. Now in this directory also let's open this file. So this is the same file in both the directories and both using the Pydantic library. Let's execute this file and see the output. So in directory 1 we get the output. In directory 2 we get the error. Now we have used the same version of Python, but the problem is that in both the directories the version of the library is different. Let's see. So here we have the version 1.10.13 of the library. And here we have the version 2.5.3. So the same code works fine in version 1.10.13 of the library, but it doesn't work in version 2.5.3. So this is the reason that we have to specify the particular version of the library also that we are using in our Python project. Virtual environment is self-contained directory tree that contains a Python installation for a particular version of Python plus a number of additional packages. The three important things that describe a virtual environment are directory tree, Python installation, and additional packages. Let's see how a virtual environment visually looks like. Here we have a virtual environment directory as venv. Specific version of Python is in venv bin directory. In our case, we have Python 3.8. Additional packages are in venv lib Python 3.8 side packages. This is the basic structure of a virtual environment in Python. Before discussing virtual environment in detail, let's first discuss three concepts: system installed Python, third-party libraries, and dependency management. Ubuntu and Mac have a version of Python pre-installed. In case of Windows, we can download and install it. This global Python is called system installed Python. Using this Python, we can run any compatible Python program. A system installed Python contains a directory for additional packages. These additional packages are called third-party libraries. Third-party libraries are open source softwares that provide us many pre-built functionalities that we can directly use in our projects. And these third-party libraries help us in developing our project faster because we have many pre-built functionalities that we don't have to code and we can directly use. The question that comes up in our mind now is, from where do we get these third-party libraries? We get these third-party packages or libraries from Python Package Index. It is managed by the Python Software Foundation. All big and complex Python projects use a lot of third-party libraries. These are the top downloaded packages. Let's see how downloading a third-party library works and how it is related to a third-party package directory in Python. For downloading third-party packages, we use a specific software called pip. Pip is the package installer program which we use to download and install packages from Python Package Index. Each third-party library has multiple versions. We can download the latest version or we can specify the specific version that we want to install. In this example, we are installing the request library. The package will be installed in system installed Python. So here we have the Python package index with multiple versions of request. We have this 2.10.0, 2.20.0, 2.30.0 and 2.31.0. We are using this command python-m pip install request, and this command will install the latest version of request. And once we execute this command, the package gets installed in the third-party libraries of the Python that we have specified in the command. In this case, we have specified the system installed Python. For installing specific version of the library, we specify the version in command itself and it downloads the specific version. In this case, we have specified the version as 2.20.0. Now executing this command will download the specific version to third-party libraries directory in our system installed Python. In a project, we might have a large number of third-party libraries and we need some kind of mechanism to manage these dependencies. In Python, virtual environment is used for dependency management. Here we have created two virtual environments, virtual environment 1 and 2, and both have different third-party libraries. This is different from the third-party libraries that is in system installed Python. And suppose we want to install a particular version of request library in virtual environment 1 only, then we will execute this command with the specific Python that we have installed in virtual environment 1. So in virtual environment 1, we have a specific version of Python installed, and from this Python we will run this command python-m pip install request 2.20.0, and this will install the specific version in virtual environment 1. In this demo, we will create a sample Python application, and in the application we will create a virtual environment. So this is the directory inside which we will have the code for our sample Python application. Let's go inside this directory. Inside this directory, we will create a virtual environment. So we have seen that in virtual environment, we are creating isolated Python installations and for installing third-party packages. So here in this directory, we will create a virtual environment. For creating virtual environment, we are using the Python virtual environment module. Since Python 3.3, we have this virtual environment inbuilt in the standard Python installation itself. So let's check our Python version. We have Python version 3.8.10. It means we can use the inbuilt Python virtual environment module for creating the virtual environments. So the command is python -m venv, where -m is for running a module as a script. This venv module is the virtual environment module that's inbuilt in Python. And venv, the last parameter venv, is name of the directory where we are creating the virtual environment. So we have kept the name as venv. So the virtual environment gets created. Let's see what are the different directories it has created. So it has created a bin include lib directory and then a configuration file. So let's dig a little bit deeper and see what is inside it. So inside the bin directory, we have a Python executable file, and then in lib we have a Python 3.8 directory where the third-party packages will be installed. To use a virtual environment, we have to activate it. The command is source venv. So we are using, to use a virtual environment, we have to activate it. So inside this bin directory, you will be able to see the activate file that's already created when we created the virtual environment. So we will use this file to activate. The command is source venv bin activate. So we are executing the activate file itself to activate it. So the Python application, so in this Python application, the virtual environment is activated. Once we have activated the virtual environment, we can run this which Python command to make sure that we have the right Python. So this command will tell us that we are using the Python that's in this venv directory inside the sample Python application that we have created. Let's see the third-party packages directory inside the virtual environment that we have just created. So this is the site packages directory that it has created. So let's see what happens if we install so we have already activated the virtual environment, and if we want to install any package, we can run this command. Suppose we want to install request library. So once we execute this command, so it downloads these packages in the site packages directory, and let's verify where these packages got installed. So we have to do a level 4. Okay, so inside the site packages directory, it shows that it has installed the request package. So this request package is specific for the installation, virtual environment installation that we have created in our project. So this way we can create specific Python version, and then we can have specific versions of the library also. And to deactivate this virtual environment, we use this deactivate command. Let's recap what we have discussed. Virtual environment in Python are isolated Python environments, and we use virtual environments for dependency management. In dependency management, we are actually managing the third-party libraries. And why we use third-party libraries? Because these help us in faster development. And we are doing dependency management because it helps in avoiding version conflict, provides stability and isolation to the project. And how we are doing the dependency management? It's through requirements.txt file and by creating virtual environment.